So in this case, and you would do this at this stage, you would just say 4.33 by 1.6 by 10 to the minus 19. And so the work function is 6.88 by 10 to the minus 19. So if you're given a value in electron volts, you convert it to joules immediately just by multiplying by this constant, which is on page 46 and 47. Okay, so we have our work function now. So we have our wavelength, we have our work function. We're asked for the threshold frequency, and we're asked for the maximum kinetic energy again. Okay. Right, so to get the threshold frequency, well, we have the work function, so we know that we have a little simple formula, phi is equal to hf0. So we have the work function, which is 6.88 by 10 to the minus 19, 6.63 by 10 to the minus 34, threshold frequency. So rearrange, and you end up getting a value of 1.04 by 10 to the power of 15 hertz. So this divided by that. Okay, that's that one done. Now, you're then asked for the maximum kinetic energy of an emitted electron. So the photoelectric effect is occurring. So we're going to use this formula. Okay. Right, we're looking for kinetic energy again. So we have H, we're looking for F. So we have to go in and get F once again. So let's do it just over here. C is equal to frequency times wavelength. Same story, you'll be getting used to this as we go along to get the frequency. So in this case, we get a value of 1.25 by 10 to the power of 15 hertz. So we fill this in down here, 6.63 by 10 to the minus 34. We now have 1.25 by 10 to the power of 15. We have the work function from originally 6.88 by 10 to the minus 19 plus our kinetic energy. So we get our kinetic energy. So we have a final answer of 1.4 by rearranging 10 to the power of minus 19 joules. And that's it. Okay, so they're the basics. Okay, we'll step them up next week. Okay, so they're the basics so far. Just to recap. We on page 46 and 47 of your tables. Okay, so I'll put them here. Okay, so page 46 of your tables here. Okay, so at the moment we are interested in this formula, electron volt. That's what we use to convert energy to joules. Okay, and what will also be useful, and you'll probably use it in one of your calculations over the weekend, is the mass of the electron. Okay, the half mv squared. On the following page, we have Planck constant, and the other one we're interested in, speed of light. Okay, and we will be interested in this unified mass unit later on, but not at the moment. Okay, so they're the five that are interested in. Look, and this is very important. Generally speaking, we're going to go to 2 decimal places. Okay, 2 decimal places, except in exceptional circumstances, we stick to 2 decimal places. So you write the speed of light in a vacuum as 3.00 by 10 to the power of 8, Planck constant 6.63 by 10 to the minus 34, and so on. Okay, so there are 3 basic ones. I'm going to give you some now for the weekend, and we'll see how you get on with them. Okay, thanks a minute. Bye-bye.